It is 9 a.m. on the dot, so we are going to get started with this morning's field trip. Welcome, first graders, to the Dallas Independent School District STEM Environmental Education Center. And we'd like to give a special welcome to a couple of schools with us live this morning. The first school is Esperanza Hope Medrano, and the second school is Mary M. Bethune Elementary, both with the Dallas Independent School District. Thank you so much for joining us this morning. We wish you could be here in person, but we're going to do our best to make you feel like you're here during a virtual field trip experience today. If you are watching this and have not registered for this field trip yet, you can still do that by going to www.tiny.cc/pk-2 registration. Once you get there, you can get yourself or your class registered for this field trip, and we just use that information for our attendance purposes. This morning's virtual field trip is going to be all about matter and energy. During this virtual field trip, students will observe and classify objects by properties such as larger and smaller, heavier and lighter, shape, color, and texture. Students will also observe changes in materials caused by heating and cooling. So we're going to start things off this morning by exploring the properties of bigger or smaller and texture with Mr. Ramirez. Next, you're going to see Mr. Monroe explore the properties of heavier or lighter. Third, you're going to see Ms. Schramm explore the properties of shape and color. And last but not least, you're going to see Mr. Dominguez observe changes in materials caused by heating and cooling. While we're doing all of that, you can ask us questions, but since this is a virtual field trip, the way you ask a question is you go to www.tiny.cc/question-answer. And once you get there, you'll fill out a very short form and you can ask us any questions you have related to matter and energy. You can ask as many questions as you like, and we'll do our best to answer all of them in the time that we have with you this morning. So let me stop sharing my screen here and turn things over to Mr. Ramirez, who's going to get us started with the properties of size and texture.
Hello, my name is Ms. Ramirez, and in this segment, we're going to be learning about size and texture. So let me go ahead and share my screen with you guys, and then at the very end, we'll meet an animal friend. So let's start that presentation. So today we're going to be observing properties of objects, including bigger or smaller, and then we're also going to be learning about texture. So hopefully by the end of this presentation, you'll be able to answer these two questions. The first question is, what are two words to describe size? And the second question is, what are two words to describe texture? So keep those two questions in mind. So before we begin, let's look at these super cute little videos. The first little video, we have a black dog and a brown dog. So think about which dog is bigger and also which dog looks softer. So think about those two questions. And hopefully you guys said that the bigger dog is, of course, this black dog with the long black fur. And he's probably going to be the softer dog because his fur is much longer. And you can see that that little dog is hanging on to his tail. And then in this other little video, listen to the question, which dog is smaller? Is it the gray dog or the white dog? So which dog is smaller? And hopefully you guys said that the smaller dog is this cute little white dog that's trying to defend his food. And then the bigger dog would be the gray dog who's giving that little dog a little boop on the head. So that's size. And then let's take a look at some more size words. So here we have a giraffe, a big bird called an ostrich, and then a person. So which of those three animals do you think is the biggest? The giraffe, the ostrich, or the person? So the biggest one is, of course, going to be the giraffe. They are really big. So if you ever have a chance to go to the Dallas Zoo, take a look at just how big and tall those animals are. Now, when we compare the giraffe to the other two animals, and yes, you guys are an animal. Y'all are a special animal called a mammal, and that is because you guys have hair on your heads. So when we talk about a person is rather big. The ostrich is even bigger, and the giraffe is the biggest. And we can use science tools like a ruler to help us measure size. We can also use our eyes to help us look at things to tell us whether it's big or small. And of course, we know that as animals grow, we will get taller and bigger. So think about how will you change as you grow up. My next word is texture. So texture is just how does something feel? And we can use our hands and we can also use our eyes to help us determine texture, how something feels when we touch it. So if I were to say which of these 4 animals, so we have animal number 1, animal number 2, animal 3, and animal 4, which animal might be bumpy if you were to touch it? So think about that word bumpy. And hopefully you guys said that the bumpy animal is animal number 1. And animal number 1 is a toad. And I know it's probably going to be bumpy if I touch it because look at those little round spots or raised bumps on its body. The next word is smooth and moist. Moist means it's almost wet. So look at these other animals. Which animal number do you think might be smooth and moist or just a little bit wet if you were to touch it? And hopefully you guys said animal number 4. This is a frog. And I know it probably looks moist because look how shiny or glistening it looks under the light. So there's our smooth and moist frog. Here's an easy one. Which animal number do you think might be super soft and furry if you guys were to touch it? So we're down to animal number 2 and animal number 3. Which one is soft or furry? And hopefully you guys said number 2, we have a fluffy cat and a super furry and soft chinchilla. Both are covered with fur. And our last one, which animal is spiky? This is an easy one because it's the last one left. Animal number 3, that's a porcupine. And I know it looks kind of spiky because it has these modified hairs that are sharp and pointy at the end, and it's rather rough to touch. So I have a challenge for you guys. I would like for you guys to go outside and find 5 nature items, describe their texture, so how do they feel, and also sort those items from the smallest to the biggest. So do that nature scavenger hunt, and I'm going to stop my screen share, and I have an animal friend that I want to show you guys. While I go pull her out, I'm going to give y'all some clues. So this animal has a beak, it has wings, and is covered with feathers. She lays eggs that you guys probably like to eat. So go ahead and think about what animal you think this is, and I'll go pull her out. So think about those clues. And of course, this animal is Pepper, the blue silky chicken. And she gets that name because she has a blue patch of skin around her ears. And if you guys were to touch her, her texture is super soft like silk, hence the name Blue Silky. So I'm going to go ahead and put our friend Pepper up. If we were to talk about her size, she is smaller than me. So of course, I am much bigger than a chicken. So I'm going to go ahead and put Pepper down. And I have an egg that Pepper laid. And I also have an egg from an ostrich. So remember that super big bird I showed you in the slide? This is the ostrich egg. So which one is bigger, the ostrich egg or the chicken egg? And hopefully you guys said it's the ostrich egg. It's almost as big as my head. And I have a little trivia question for you. How many chicken eggs, the yolks, that yellow part, do you think can fit inside an ostrich egg? So go ahead and give me a guess, any number. And the answer is 24 chicken yolks can fit inside an ostrich egg. So that's a lot of omelets or scrambled eggs that you can make out of an ostrich egg. Pretty cool. So something else you can do, you can use a ruler to help you measure how big this egg is. And you can even use blocks. So this chicken egg happens to be about 8 blocks big. So we can use different things to help us. And we also have some more eggs from birds all over. And take a look really quickly. See if you can find the largest egg and the smallest egg. And you can point at the screen, or maybe a teacher wants to have someone come up and point at the screen. Find the smallest egg and the largest egg. And I'll give you a hint. That smallest egg is in the middle of your screen, and it belongs to a bird that we actually have out here. And it's this super tiny egg right here. It belongs to the hummingbird. And the biggest egg would probably belong to this bird. It's called the common loon. It sort of looks like a duck, but it's not quite a duck. So look at all those different sizes and colors for those eggs. So that's all I have for you guys today. We're going to give it back to Mr. Broughton, and he'll answer any questions.
Thank you, Ms. Ramirez. The question that came in was, what is the largest animal in the world? And that would be the blue whale. It can weigh up to 400,000 pounds, which to compare that to an animal you maybe have seen at the Dallas Zoo or someplace like that, that is as large as 33 adult elephants. And it can be about 100 feet long. And so to give you an idea of how far that is, if you have tiles at your school, which you probably do on the floor, those are 1 foot long. So if you were to count 100 of those, that would be how long a blue whale can grow to. All right, now we're going to learn about the property of heavier and lighter with Mr. Monroe.
Good morning, students. My name is Mr. Monroe, and we're going to be looking into two words that describe the property of matter. Now, you heard Ms. Ramirez talk about bigger and smaller, right? Well, the words that we're going to be looking into are heavier and lighter. I've got a dumbbell right here. And usually people would use this dumbbell. Well, that's old Smokey, the smokestack, making all that noise. So hopefully he'll get quiet here in a little bit. But listen, dumbbells are used by people who want to exercise and build up muscle. Now, they use a variety of exercises that cause them to lift this. And indeed, when lifting this, you can determine that it's pretty heavy. If we compare this dumbbell with a feather, this is lighter, this is heavier. There are a lot of objects in our world today, students, that sometimes it's very hard to determine which is heavier and which is lighter. And believe it or not, there are some scientific tools that we can use to determine that. One such tool, and maybe you've already used this, or maybe you're going to sometime during the school year, it is called a balance. And this balance is used to compare the weight of objects. Now, listen, I want you to remember what that word weight means. So I'm going to tell you. You know, weight means how heavy an object is, or how heavy a person is. How much I weigh would be my weight. How much the dumbbell would weigh would be its weight, okay? Now, I want you to remember that because your teacher just might ask you that question later on. There's something else I want you to kind of get an understanding about too. You heard Ms. Ramirez talk about bigger and smaller. So most of the time when we see an object, for example, the dumbbell, it was much larger than the feather, right? So we always assume, or we think, that the bigger object is going to weigh or be heavier than the smaller object. I don't believe that's true. So we'll look into that further along in my part of your virtual field trip today. But this is a balance here, and they come in a variety of styles. This one is very colorful. It has containers that you would put an object in to compare their weight. And of course, if you put something heavy in here that's heavier than the other object, the box or the bucket would go down. Better yet, let me show you. I have two rocks here, and we know that rocks are made out of different materials. Rocks can be made out of different things. Some of those things that the rocks might be made out of, in fact, I'll tell you a little secret. What rocks are made out of, we call minerals. Some minerals are heavier than others, and some minerals are lighter. I have a very interesting rock here as compared to this rock. We can see that this rock is bigger and this rock is smaller. So I'm going to put this rock in the yellow one, and I'm going to put this rock in the red bucket. Wow, it didn't move, did it? So that tells me the yellow box is staying down, and that tells me that this rock right here is heavier. And yet this rock is bigger, right? So it goes back to that thing about just because something is bigger than another object, does that always mean that the bigger one is going to weigh or have more weight? Well, you know, I pulled a little trick on you guys today because I know what this rock is made out of, and I know what this rock is made out of. This has a metal mineral in it, which means it's going to be heavier. And this other rock, listen, I call it a magic rock. Have you ever heard of a rock that floats? Well, look, I'm going to put this rock in the water and look what happens. It's floating. And it's floating because of what that rock is made out of. Now watch the smaller rock that we compared with it. Watch what happens there. It went straight to the bottom. So, you know, I've got a couple of animal friends that I want to share with you today. And it goes back to that part about bigger and smaller. But it also lets you know that most of the time, if something is larger, depending on what it's made out of, most of the time it is heavier. Well, I'm going to get Hoppy Sr. and Hoppy Jr. out, and we're going to look at their sizes, and we're going to determine which one is heavier and which one is lighter. Bear with me. This is Hoppy Sr., this is Hoppy Jr. They are bullfrogs. Now, we couldn't really compare them by putting them on the balance, could we? Because they wouldn't stay still long enough. They'd probably hop right out. But looking at these, and if you were able to hold these guys, you would be able to figure out that Hoppy Sr. is a lot bigger and heavier than Hoppy Jr. So most of the time, it is true, the larger object is going to weigh more than the other or the smaller object. But that doesn't always happen to be true. As we have proven, I'm going to put these guys up. And there are other scientific tools that you can use to determine the weight of objects. One is called a bathroom scale. This is what people would use to figure out how much they weigh, usually found in a bathroom. I could stand on this and it would tell you how much I weigh. Also, there's what we call a spring scale. They're usually called scales. And this, you would hook it onto an object and pull it up, and the object's weight would pull this down, and it has units of measurement on it. That would tell you how much an object weighs that way. And then we have another spring-loaded scale that has a container and on the top where you would put the object that you want to weigh, such as this heavy ball, and that's what you would get. It would tell you how much that ball weighs. And then there are some very large scales that are used to measure the weight of 18-wheelers and their load. And you can find those at weigh stations all along the highway across this great country, the United States. I want you guys to have a good rest of your virtual field trip today and a good day the rest of the day. I'm going to turn it back to Mr. Broughton. So if any of you have any questions, I bet he can answer them for you. Have a good day.
Thank you, Mr. Monroe. The question that came in was, how could we get the real weight of that bullfrog? And one thing that scientists can do is take an empty cage or container and weigh that, and write that down so you know how much that weighs, and then put that bullfrog in that cage and weigh it again, and write that down. And then the last step is to subtract the weight of the empty cage from the weight of the cage with that bullfrog, and that would tell you the weight of the bullfrog, and it wouldn't be able to get away either since it was in the cage. One other thing you can do to explore weight is the next time you're in a grocery store, look for scales. You'll be able to find them and figure out how they work. All right, now we're going to look at the properties of shape and color with Miss Schramm.
Good morning, everybody. All right, let me share my screen really quick. And okay, so I'm Miss Schramm, and we are going to be exploring shape and color in nature. So you will be able to observe and record properties of objects, including their shape and color. So these are the different shapes that we are going to be looking for today. We've got our squares, our rectangles, hearts, circles, hexagons, ovals, stars, triangles, pentagons, and trapezoids. And we have our little color chart here. Okay, so when you think of red in nature, you might be able to find a fish like this betta fish. You might think of ladybugs. When you look for orange, you might find a monarch butterfly or fall leaves. When you look for yellow, you might find yellow birds or lemons. When you look for green, you might find different plants like this fern or different reptiles and amphibians like our little frog. When you look for blue, you might see a blue butterfly or the ocean water or the fish in the ocean. When you look for purple, you might find sunsets or flowers. When you look for pink, you might find cherry blossoms or pink flamingos. When you look for brown, you might find grizzly bears or the wood from a tree. When you look for gray, you might find a gray wolf or gray cloudy skies. And when you look for black and white, you might find a spider web or my very favorite animal, the panda. Oops. Okay, so we're gonna play a game where I'm gonna post a big picture of something from nature, and I want you to try to find what color and shape you see. So we have a big honeycomb with a honeybee, and I'm looking and I see a shape that's repeated over and over. And if I look closely, I can count 1, 2, 3, 4, 5, 6 vertices, or the points, right? So we have 6 sides and 6 vertices. So hopefully you see yellow hexagons. Now, of course, I can't hear you if you're guessing correctly, but you'll be able to know when I tell you the answer. All right, the next one, we have onion slices. So someone took an onion and sliced it down the middle and laid out all the slices so we could see inside the onion. So I'm looking at this one down here, and it's pretty round. I don't see any vertices or sides. It's just one round shape. But it's not perfectly round. So hopefully you are also seeing a purple oval. Ovals are just like circles with their rounded edges, but they're a little bit squished. So I see a purple oval. All right, next one. All right, this flower, I'm looking at the outside of the petals. So if I look at the outside, I see 1, 2, 3 vertices and 3 sides. If I would draw a shape around this flower, I would see a big white triangle. The flower is mostly white, even though it has other colors inside, and it makes a triangle with 3 sides and 3 vertices. All right, next is my favorite example. This special leaf has 2 rounded edges on the top, and it meets at 1 point down below. So hopefully you are seeing a green heart. All right, this one gives away the shape right in the name. It is a starfish. So we know the shape is a star because it has 1, 2, 3, 4, 5 vertices, but it goes in on the sides as well. So it has a vertice and it goes right back in to make a star. And so here we have 2 orange stars. All right, our next one is cut logs. So somebody cut down these trees and chopped the logs so we can see inside, just like they did with the onions. So if you look close, I see rounded edges. And as the tree grows, it creates rings inside. So hopefully you are able to see a brown circle. There's a bunch of brown circles getting smaller as you go towards the center and getting bigger as you go to the outside. All right, here is the cardinal climber vine. Now this one reminds me a little bit of the starfish, but the shape is a little different. So if you look on the outside, I see 1, 2, 3, 4, 5 vertices and 5 sides. But unlike the starfish, the sides are straight down. So this one is a red pentagon. So you might be wondering, why are there so many different shapes and colors in nature? Well, there are 3 main reasons that plants and animals have adapted and made different shapes and colors. So the first reason is it helps them camouflage. So the first example is a leaf insect or a leaf bug. Now he eats leaves and he looks like a leaf himself. So predators that might want to eat him are not going to see him because his shape is like a leaf and his color is like a leaf too. Another example of a great camouflager is the chameleon. The chameleon is green and yellow and has little spots of blue, and it can blend in with the leaves and the trees where it lives. Probably the most interesting one is the leafy sea dragon. He blends in with the kelp and seaweed around him because the shape of his fins look just like kelp and his color looks like kelp too. Okay, so another reason for many colors and shapes is to warn off predators. This first example is a plant called poison ivy. Now, poison ivy can make you really itchy. So if you look closely at the plant, you will see red, bright red stems and leaflets of 3. So there's 1, 2, 3 leaflets in this bunch of leaves. So if you've ever heard the phrase, leaves of 3, let it be, those shapes are warning you, don't touch me or you're gonna get really itchy. The next example is the puffer fish. He starts out very small, but when he feels threatened or feels like a predator is coming, he changes shape by getting really big and using his pointy spikes to scare off predators. And our last example of warning off predators is a poison dart frog. So these poisonous frogs have beautiful bright colors and patterns that tell other predators, don't eat me because I am toxic. It's like a big red stop sign saying, don't eat me or you'll get sick. All right, and our other reason why animals and plants have developed different colors and shapes is to attract pollinators and mates. The most famous example is the peacock. The male peacock uses its big, fancy, colorful feathers and bright shapes and patterns on his feathers to try to attract another peacock, a female peacock. So he wants to look so handsome so he can get a girlfriend. Then the next example is the flowers. When you see those beautiful summer blooms, the brightest, most beautiful flowers are more likely to attract bees and butterflies and birds and other pollinators so that they can spread their seeds and make more flowers for next year. Okay, so my challenge to you is next time you go outside, try to find even more shapes and colors. All right, I'm going to hand it back to Mr. Bratton. Have a good day.
Thank you, Ms. Schramm. And your challenge question at the end fits right in with the question that came in because a student asked, can I go outside and see more examples of shapes and colors in nature? And yes, you can. So ask your teacher if they can take you on a walk through the school garden or around your school. And you can also ask your parents if they can take you on a walk through your neighborhood. And I bet you will see some more examples of shapes and colors in nature, including camouflage or warning colors or pollinators. So I encourage you to go on that walk. All right, now we're going to learn about heating and cooling and what that can do to matter with Mr. Dominguez.
Hi guys, it's Mr. Dominguez from the EEC, and in this portion of your virtual field trip, I will be talking to you guys about the effects of heating and cooling on the properties of matter with my helper here, this Leachianus gecko. And this Leachianus gecko happens to be the biggest species of gecko in the entire world. And you may be wondering, why does Mr. Dominguez have this pretty mean looking lizard as his helper? Well, she's a cold-blooded creature. So what does that mean? Well, that means that her body cannot produce her own heat like ours can. So if you just touch your cheek, you'll feel some warmth. Now, if I were to touch her, she feels kind of cold at the moment. Not so cold because I've been holding her and some of my heat has been transferring over to her body. But this poor little creature is very dependent on the outside warmth that she gets from her environment, mostly from the sun. Now, why did I choose her? Well, out of all the creatures that I have, I like her the best because she likes to jump and she can't stand still. I know your teachers know all about that sometimes, but I just find her to be cute. Now, I think also she would be very appreciative of all things heating and all things cooling. Well, maybe not the cooling part. So in this demonstration, I'm going to be applying some heat to some, not lychee, but to some abiotic, that means non-living things, like crayons, a stick of butter, and some chocolate to see what happens to their properties. Now, how am I going to be doing that? Well, I'm going to apply some heat in the form of fire. And right after I apply that heat with the help of lychee, maybe not, maybe I'll have to put her up, I am going to cool them down with some compressed air. You guys hear that air? Did you guys just see lychee fly off? Now I think I'm gonna put her up so I can begin my demonstration. Now, if you ever have a classmate that is disrupting learning, tell your teacher, and your teacher will put them away in their enclosure. I'm just kidding. That won't happen. Don't do it, teachers. Anyway, stay tuned. All right, guys, I am back. I've put up lychee and I'm ready to go. So remember, I'm going to demonstrate what is going to happen to 3 items, chocolate, butter, and a Crayola when I apply heat to them. And then after heating them, I am going to cool them down. And we are going to observe what happens to the properties of matter. Now, acuérdense amigos que en este experimento les voy a demostrar qué ocurre cuando aplico calor a 3 cosas. A un pedazo de chocolate, a un pedazo de mantequilla y a un pedazo de Crayola. Si quieren, tomen un momento y escriban lo que piensan que va a ocurrir cuando estas tres cosas se calientan. So if you'd like to make a guess as to what's going to happen when these things are heated, go ahead and pause the video and write those guesses down, because I already see some changes happening. As you can see, the butter is already changing. The chocolate doesn't seem like it's changing, but I see the very edges doing something very interesting. The Crayola hasn't changed. I may have to apply a little bit more heat to it. So remember, we are observing what is happening to these items. And remember, all of these items were solids. The chocolate was brown, the butter was yellow, and it was kind of soft, but it was still a solid. And the Crayola was definitely a solid, and it was very hard, and it had a very smooth texture, but it was definitely a solid. Now I can already see something happening to the butter. Can you guys see that? ¿Pueden ver lo que está pasando a la mantequilla? Se está derritiendo, ¿verdad? It's melting, isn't it? The butter's melting. Now, the Crayola isn't melting at all, so we might have to give it a little bit of help. So let's give it a little bit of help in the form of a blowtorch. Let's see. Do we see anything happening to it? I do. It's melting, isn't it? It's definitely melting. It melted. Now, I am willing to bet that if I kind of move my hand around here where the chocolate is, I'm pretty sure that it already began melting. Entonces, estoy observando que mis tres pedazos de materia se han derritido. They've turned into a liquid, haven't they? Mis tres pedazos de materia se han convertido a un líquido. Y también puedo ver que la mantequilla se ha convertido un poquito más transparente en color. So what I'm noticing too is a change in the butter's color. So the color of the butter used to be more of a very solid yellow. Now it's more of a very clear, see-through, yellow still, but more see-through color. Now, what I'm going to do is I'm going to blow out my candles. Le voy a soplar a mis velas. Feliz cumpleaños, ¿verdad? Feliz cumpleaños a esta materia. Happy birthday to this matter. And I'm going to cool it down. I'm going to cool everything down using a little bit of compressed air. Now, as you can see, the crayon already turned back into a solid very, very quickly. Now, these two other pieces of matter, the chocolate and the butter, may take more time, so I may have to take them to the refrigerator to help things speed up a bit. But I can already see the butter's color turn back into that original yellow. Entonces, enfriando a mis tres pedazos de materia, puedo ver que se están convirtiendo otra vez a sólidos. Now, I am going to take these to the refrigerator, so we're not here using this compressed air all day long, right? It might take us too long to do that. So, we'll be back. And what do you guys think is going to happen to the matter? So is it going to turn back into a solid? And I have another interesting question. What if I just kept these three pieces of matter, just heating up and heating up and heating up, what do you guys think would happen? That's another very good question to kind of discuss among yourselves. Okay, so I'll be back. I'm going to put these things in the refrigerator and we'll see what happens to them next. So as you can see, all of the items that I melted and turned into a liquid turned into a solid. There's that crayon. So solid, solid. Now, the shape did change, however. So the chocolate that was once a square, after I melted it, took the shape of the container, and so did the butter. Now, I'm sure that if the crayon had melted some more, the same thing would have happened. So, what observations did you make about heating and cooling, and how do those things change the properties of matter? Thank you guys, and I can't wait to see you guys for our next virtual field trip.
Thank you, Mr. Dominguez. And the question that came in was, what other materials can I test to see what happens if I heat or cool them? And there are many other materials that you can test, but do not test anything until you talk to your teacher at school or your parents at home first to make sure that whatever you're trying out is safe. They will know if it's safe for you to do that and will be able to help you. I'm going to share my screen to do a quick recap of what we did today. And there we go. So again, this virtual field trip was all about matter and energy. So we started things off by exploring the properties of bigger or smaller and texture with Mr. Ramirez. Second, we explored the properties of heavier or lighter with Mr. Monroe and even used a pan balance and some different scales to measure weight. Third, we looked at shape and color and why things are different shapes and colors in nature with Ms. Schramm. And last, you saw that really cool experiment with heating and cooling with Mr. Dominguez. Thank you so much for joining us this morning to explore matter and energy with us. We hope you enjoyed this field trip. You can let us know whether you did or not by going to www.tiny.cc/pk2-feedback and filling out a short feedback form for us. We use that information to improve what we do. And we can't wait to see you first graders again for our next virtual field trip that will take place in about 3 weeks. Have a great rest of your day and we'll see you next time. Goodbye.